to 6G evolution, sponsored by Qualcomm. Before we begin, I will cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to your question, we will follow up via email. At the bottom of your audience console are multiple application widgets that you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the blue Resource List widget. Near the end of today's presentation, please take 1 minute to complete the survey that's open on your screen. Your feedback is extremely helpful. Also, an on-demand version of the webcast will be available about 1 day after the event, and you can access that using the same audience link that was sent to you earlier today. Now I would like to turn the event over to Heavy Reading's Principal Analyst, Gabriel Brown. Gabriel, over to you.
Thank you, Michelle, and hello, everybody. Welcome to Light Reading's 6G Symposium. It's terrific to have you with us. Thank you for coming. The session, as you can work out, is on 5G to 6G evolution and how that might play out. We're really excited to be here. I personally am super excited, and I think you're going to hopefully find out why as we go through the session today. As you heard, my name is Gabriel Brown. I'm an analyst with Heavy Reading, where I cover mobile networks. I'm your host and moderator for the session. Heavy Reading is a part of Omdia, which is one of the world's largest tech industry research firms. So in terms of agenda, I'm going to give a short introduction in just a moment. We'll then hear from our operator keynote, Brian Daly from AT&T, followed by our sponsor keynote, Hemanth Sampath from Qualcomm. We then have an operator fireside chat with Hardouin from Orange. That's actually a video that I recorded with Eric for the event just over a week or so ago. Eric's on holiday this week, so couldn't make it with us live, but he's done a dedicated video and some really interesting information and points of view in that. I think an important point to make with Orange, obviously you guys all know AT&T very well. Orange also, it's an operator with 26 countries of operation, and that translates into roughly 280 million direct mobile subscribers globally. So it's well worth listening to that video as we go. From there, we'll roll into our panel session, where we'll be joined by JD Griffiths from the NextG Alliance. We're going to take audience questions during the panel, but if you do have a question for Brian or for Hemanth after their presentation, if you get that in, I'll be keeping an eye on the background, so I'll try and work in a couple questions as appropriate. If we can get that done as we go along. So. And we have some great speakers here, so do ask questions. I know everyone's up for it as well. So I'm going to get into my opening remarks here. The chart is showing really some of the key themes from the 3GPP 6G plenary held in Korea in March this year. This was a workshop for members to share their views ahead of the formal start of 3GPP standards work in Release 20. It's a goldmine of information, a ton of material presented. A lot of it was actually a comment on 5G in many ways. But also looking ahead to what the community wants from 6G. We picked out these 6 kind of interlocking themes that you can see on the chart. I'm not going to go through all of it. There's a lot there, and you can kind of have a read and a skim as I'm talking. I've sort of distilled it down really to three main points. The first is we kind of have an idea now that the day one architecture should be and will be 6G standalone from day one. It'll use existing spectrum with MRSS. And new spectrum as well, and you can see some of the commentary around that. The other big point, second one, is the community, particularly on the operator side, are interested in a simplified, practical, and 6G that's focused on user value. Eric talks a lot about that in his video. It's interesting that in terms of, like, for example, raw end user performance, things may be kind of incremental there. If we think 5G peaks today are amazing, right? I just saw a speed test last week on the new iPhone running the new modems and everything. A 4.9 gigabit per second downlink in the real world. That's in America on a millimeter wave spectrum, of course. But it's pretty much commonplace that you're getting a gigabit downlink now to mobiles on sub-6 spectrum as well. So that's immense performance we have already. Where there are going to be big opportunities, I think, is to improve the overall user experience, and that's something we'll get into in some of the talks. We also have this idea of a kind of a needs-based hardware refresh, and that's very strong in the operator community. You can see that's a reference to AT&T submission on the chart here. Obviously, they're speaking in a moment. It's also referenced by Orange in the video. I heard it yesterday as a presentation from Vodafone in the UK. They've just announced their big RAN refresh project for a big merger there. They're making that point very strongly as they roll out that equipment. Many other operators, for example, members of the NGMN are strongly making that case. Now, we are going to need new hardware. We're going to have new spectrum. We're going to need new hardware on the infrastructure side and on the device side. But this idea of, it doesn't have to be all at once is quite strong, I think, in the community now. Operators are also saying they really want to see clear benefits from 6G, and they're going to benchmark that to 5G Advanced. So that's a big bar, that's a high bar to clear. Alongside that, we want new 6G capabilities. So these are generally going to be related to things like sensing, network computing, probably for AI, and what we might generally term service-aware capabilities. So we think, for example, there, XR-type applications, AI-enabled services of all kinds, and maybe, I think the way to put this, but kind of multi-device user scenarios is something Qualcomm will pick up in their talk in a moment. I have to say, there's really a lot going on. This chart was based on a meeting in March in Korea. Since then, we've had the 6G radio and 6G architecture study items were approved for Release 20 in the Prague meeting, I think back in June. And then just last week in Beijing, there were important RAN meetings with lots of 6G content in there as well. And honestly, it's really a lot now to keep up with. Like you need a full team of PhDs and lifetime, career engineers with radio and mobile network background. It's kind of, there's loads of stuff going on. It's super interesting. And, it's now, as I'm going to demonstrate, I think, and make the case now is really the time to be paying attention to this. The challenge, sort of in simple terms, is to design a system that's going to evolve to meet the demands of the kind of services we might be using in the 2035 to 2040 timeframe, but with an initial deployment model that can be supported within the economic kind of envelope of today's business models. And how we do that is obviously a big part of what I'm going to be talking about. We don't really know what we'll need in 2040, but if we look across the technology landscape at a very zoomed out view, I think there's every chance it's going to be epic, like really epic. If you look at everything that's going on in autonomy, in AI, in robotics, in non-terrestrial satellite and drones, in the energy system, in the biosphere and environment, you name it, there's tons of sectors and things where it's just absolutely on fire. And we know that all of these domains are going to somehow require an immense amount, an immense variety of connectivity to go with it. So, there's a huge amount to be kind of like buzzed about, basically. I think from our vantage point in 2025, where we are today, I've set out the next 15 years in 3 segments. Obviously, it's not going to be as neat as that, but it's a way of thinking about things. We're moving now into a really very cool phase with 5G. We're going to see strong SA networks everywhere. 5G Advanced is introducing some fantastic capabilities, which are really going to take us right into 6G, I think. A ton of things there. Roughly, we're looking at around about 2030 for the first 6G launches, and that is really not that far away. I think if I could make one point today, some decisions on sort of system architecture, on the RAN architecture, on the radio interface that are going to really determine the long-term shape of 6G are being made in a really quite a short time frame. That's happening right now. So it really is the time to sort of pay attention. I'm going to hand over to Brian. The thing I just also put on here, you see the 2 different Olympic logos, LA in 2028 and Brisbane in 2030. These are kind of an alternative timeline. There's always an opportunity to showcase, for example, some prototype and pre-standard technology perhaps in LA, and then we'll be looking at a more full-fledged type system. I'm estimating in and around Australia in 2030. Let's hope the Australian guys are working on this now already. So with that, I'm going to push on to our keynote speaker. I'm delighted to introduce Brian Daly, who's AVP of Wireless Technology Strategy and Standards at AT&T. Brian, I see your camera is on. Your first slide is up. And before you go, just a reminder, people put your questions in. I see a couple coming in already, but do take advantage. Brian, please, you're in control and take it away.
Very good. Well, thank you, Gabriel. That was an excellent introduction and an excellent overview of where we are on this path to 6G. So, yeah, I'd like to talk a little bit about what understanding 6G from an operator perspective. And one of the questions I get, both internally and externally is, well, why 6G now? Well, what's so special about needing the 6G now? And, I go back to the ITU and the ITU process where they come up with a vision for the next generation of international mobile telephony. And they develop their vision statement and the requirements leading to their, IMT specifications that occur on these 10-year cycles. And when I think about it, go back to the past, there's really three angles to the G cycles. One is the operator investment cycles. One is the technology development cycles. And then there's the geopolitical cycle, as I'll call it, with the ITU being a treaty organization and trying to, put together spectrum strategies and radio requirement strategies on these 10-year cycles. It made sense, when the three aligned, when you have an alignment between the technology cycles and the operator investment cycles, especially in the early Gs, there was close alignment. Every 10 years we had major advances which required radio refreshes and significant advances in technology. But as we're moving now towards 6G, we're seeing a bit of a disconnect between those because, and I'll get into this in the next slide. We've got the operator investment cycles and the technology development is really misaligned with a 10-year cycle. So we recognize that 6G is coming. The train has left the station on this. The ITU has developed their vision and definition for IMT 2030. They're in the process of developing their requirements and evaluation criteria. At some point, we'll have 3GPP, in release 21, complete the normative specifications that will flow back into the evaluation process. And ultimately, we'll get IMT 2030 specifications out of the ITU and 6G specifications out of 3GPP. And I know JD is going to be on the panel later, so I want to put the plug in for the Next G Alliance, of course, which does the pre-standards research activities that feed into this process as well. So, as I mentioned, seeing some disconnect between some of the operator investment cycles and technology, we're moving more toward a continuous innovation, continuous disruption cycle. The ongoing network transformation is looking towards a long-term architecture. And when you look at this, within AT&T, our transformation is going to modernize nearly every one of our cell sites in this process. And those investments, that we're putting into the ground now need to last into the 6G timeframe. We see that the 6G deployments, we don't want to see a complete overhaul of hardware to realize the benefits. So on that first slide that Gabriel had put up, we need to make sure that any hardware refreshes are really done to give us significant advances that we're looking at. And as we look toward this continuous innovation, continuous disruption cycle, it's all driven by the fact that we're seeing more software-driven deployments. We're seeing cloud deployments in the core network. We're moving toward cloud RAN, more virtualization, and software-driven deployments with existing open radios and legacy bands, leveraging 5G and 6G MRSS where and when needed. We see the full capability of 6G realized with radio refresh in existing bands or a new greenfield bands that are driven by the business needs. We also see the need for a new testing and certification paradigm to allow us to enable features as needed and when needed. When we look at 3GPP specifications, there's quite a bit of options that are put into the specifications. So some of those options don't get fully tested and may not be deployed. So we believe that a new testing and certification paradigm is needed so that we can look at, test, and deploy those features that are in 3GPP specifications when they're actually needed. So 5G, there are a number of network challenges that we have seen, and we want to see those addressed by 6G. And that's a continuous process. Again, getting into this continuous innovation, continuous disruption. Some of these we can't wait for 6G to address, so we need to continue advancing the specifications for 5G. But others we can see 6G needs to focus on, and that includes exploring new services and revenue opportunities, look at major performance and efficiency improvements so we reduce our total cost of operations and improve the customer experience, as well as introducing enhancements and support for existing services. And 6G will address challenges that 5G does not address well. And that includes things like native AI and integrated sensing and communications. When we look at 5G, 5G monetization obviously is one of the big issues and challenges that we're addressing. And when we get to 6G, certainly we're going to have the same questions. How do we monetize the technologies that are being brought into 6G? Gabriel mentioned the SA core, going from non-standalone to standalone was a huge challenge for the industry. And as Gabriel mentioned, when we move towards 6G, we want to see SA from the start, a standalone from the start. We also seeing some fragmentation in the verticals, different demands and different requirements from different vertical segments. We need to address that. Of course, capacity and spectrum is something that we always have to address no matter what generation of technology we're talking about, as well as coverage, especially on the uplink. We want to address cost efficiency and energy efficiency and operational efficiencies as we move towards 6G. Security, of course, is always a big concern that needs to be addressed. And as we move into the 6G timeframe, there's going to be even additional security concerns that we'll have to look at. Bringing in zero trust, as well as addressing post-quantum are two of the areas. And the network is very complex, and we need to address the complexity of the network. Certainly moving toward the service-based architecture in 5G does reduce some of that complexity and add some flexibility, and that's part of the entire network transformation, as well as bringing more openness in. As we like to call it, we'd like to see 6G open from day one, both on the radio interface for Open RAN, as well as introducing APIs that allow more openness in the information that's provided from the core network. And of course, we want to tap industry innovation. We want to see continuous innovation and continuous disruption as technologies become available. The trends we're looking at, obviously, cloud native is something that has been in place since 5G. We want to make sure 6G facilitates cloud native approaches so that we can see continued softwareization of significant functionality of the network, including the RAN. We want to see more adoption of the service-based architecture and open API approaches. And of course, with that, we need to make sure it's secure. And this will enable spinning up functions on demand and changing them as needed. AI, open source, and white box network components are the second technology trend we see. Automated code generation for standards for network modules, and further integration of software communities with standard process. And this will allow for quicker testing of features and improved time to market. And finally, network and service enhancements. AI obviously is big. AI-enabled modular independent with granular network components end-to-end with network automation. We want to see a blurring of the line between the RAN and core. Co-locating of RAN and core modules will result in different network deployments. Defining new services and exposing network capabilities, supporting and enhancing legacy services, as well as revisiting the legacy protocols that are in the network. On our priorities, obviously software-driven network, as I already mentioned. We want to see more software-driven deployments with a needs-based hardware refresh, scalable designs that allow us to support diverse device types, including LPWA on day one. The new paradigm for testing and certification, as I mentioned, to globally align test and certification procedures that will enable mandatory features. Integrated native and native AI ML framework to give operator visibility and control of data collection, as well as integrated model training. And finally, sensing as a service, which is one of the big new areas that 6G is bringing. Having the network as a sensor, what new use cases will that enable, and what new services will that enable? Security, as I mentioned, we need to have security from day one, not being an afterthought. Certainly zero trust and bringing in the zero trust maturity model into 6G is going to be important so that we have a trusted, secure system. We need to see security controls so that we maintain confidentiality, integrity, and availability across the entire operator network, including all 6G components. As we bring more intelligence to the network, we may need to make sure that AI both can be used to automatically advantage security, but we also need to make sure that AI in itself is secure as we bring it into the network. And I already mentioned post-quantum as being one of the areas. As we move into the 2030s and beyond, we see that post-quantum cryptography is going to be needed within the network, that we bring quantum-safe algorithms in for authentication and integrity protection. And zero trust, again, we want to move our 6G defenses away from static network-based perimeters to focus on users, entities, assets, and resources, and incorporating the zero trust architecture and maturity model. And that, is a brief overview of what AT&T sees as we move into 6G. And again, our biggest theme is continuous innovation, continuous disruption, and as we move forward.
Fabulous. Thank you, Brian. A terrific summary. So many of those points we could drill in on and spend an hour, a day, a week and getting into them. And especially, I think, important that you kind of referenced and made the security piece part of the, the main thread here. So it was a dedicated piece of your presentation, which is very notable. And very quick question or two, Brian, and don't feel you have to give like definitive answers or anything, because obviously there's these things that there's some uncertainty around. One question though, and if you just talk broadly around it, I guess, what are the key 5G advanced features that are needed for the baseline for 6G? I referenced that in my introduction. Maybe you could just comment a little bit on how 5G advanced maps into 6G, and obviously on the baseline side, I guess it's going to be things like spectral efficiency, downlink at 5th percentile, user area capacity. These are the sort of benchmarks that I've seen are being referenced.
Yeah, when we look at 5G and the three legs of the triangle, as I'll put it, that the ITU comes out: enhanced mobile broadband, massive machine type communication and ultra reliable low latency communications. I think those build the base of what we're seeing as we move into 6G, and we need to get those performance of those three legs intact as we move into 6G. Because if we look at the wheel and pallet diagrams as we go into 6G, those are still there. Those haven't changed. We'll see more performance requirements come from the ITU for those three. But building upon the spectral efficiency, the bandwidth requirements, the number of users within a given area, all of those have to be in place and are built upon what is being done in 5G Advanced as we move to 6G. Now they do add the additional, ubiquitous coverage and AI and ISAC into the wheel diagram for 6G, but the basic framework comes from what we're doing in 5G and Advanced.
Yeah, thanks. And I think it's also from my side, I guess I'm looking at a lot of some of the 5G advanced service capabilities. I'm thinking of things like ambient IoT, kind of some early forms of sensing, location, the AI framework, XR, NTN. These are all 5G advanced things that maybe we'll see full fruition in 6G, I suppose, is one way I'm looking at it.
Yeah, you're exactly right. Many of the things that we're building in 5G will carry over into 6G. They're not unique to 6G, which goes back to my theme of continuous innovation, continuous disruption, right? It's really independent of a G. We just like to see that natural transition. So NTN, obviously, that's something that we're seeing come into play now, with some of the direct to cell direct advice services that are emerging. So NTN ties into the ubiquitous coverage that 6G is looking at. Even ISAC, there are capabilities that can be done, in 5G Advanced, but 6G, really spells it out as being one of the capabilities. But you're exactly right. Many of the features and services that are being developed on 5G Advanced will carry into 6G.
Yeah, and just a quick one, and just if you give a quick feedback on it. And this question's, I think, maybe a little bit of a leading question, but I'll just give you a chance to comment. So the question, as I'll just read it out as it is, what resistance, that's the leading part, what resistance do you see from vendors and operators in regard to openness in 6G, 3GPP standardization? Is that an area of contention? Is openness going to be handled by O-RAN Alliance only? Now, obviously, that by nature, standards are open, I guess. So that's just
Sure, and you mentioned the recent meeting in Beijing, and there was one major agreement that came about was to actually reference the O-RAN Alliance as being one of the options for the front haul interface in the 3GPP specifications. So I think we're, as we move forward, certainly open from day one is our theme. We would like to see, more openness in the architectures to allow more flexibility in vendor choice and deployments. And, I think, as we move forward, I think we'll see more of that theme be brought into 6G. Certainly, we've got groups like the O-RAN Alliance also developing specifications for open radio access networks. We're seeing, the APIs on the network side, which allows more third-party applications to be brought in. As we see more intelligence brought into the network and applications being developed based on intelligence, I think we'll see more evolution toward openness.
Okay, fabulous. Thank you, Brian. So Brian's going to be back with us in the panel session. We have some other great questions for you, but keep them coming. While Brian's having a look at those on the background, we're going to push on to our next speaker. I see Hemanth from Qualcomm has put his camera on. Hemanth, are you there?
Yes, I'm here. Can you hear me okay?
I can see and hear you very clearly. It's on your first slide, so take it away.
Well, first of all, thank you for the introduction, Gabriel, and then great to follow up with what Brian has laid out so beautifully for 6G. Today's, my talk is going to be about empowering new generation or next generation user experiences and scale with 6G. And right off the bat, I'd like to start with how the consumer or the user behaviors are already changing. Today, largely, we have a smartphone-centric user-initiated content consumption. It's all app-based. But as we move to a world where smartphones get attached to also a watch, a glass, and also using voice-based interactions, that is really going to change, where you have persistent context-aware AI agents that are continuously observing, sensing, and inferring, right? So you're going from a very downlink-initiated app-based traffic to a much more natural interaction driven by AI. And so that is really we feel is going to drive sustained traffic growth, especially uplink, driven by these AI agents, whether it's on a glass, a watch, a phone, or a puck, where you're going to be naturally conversing with it. The glass is going to see what you're going to see. The watch can know your personal context and so on. So whether it's like ordering an Uber ride, or you want to look at your next schedule, it's going to be a much more natural user interface than essentially typing on a keyboard. And the other big trend that is happening is, as more and more devices become embedded with these AI agents beyond the phone, right? You can have a glass, you have cars, you have an AI PC. And so there's going to be a natural need for network connectivity, because you're going to be able to run some of these models on device, but you'll also need access to the network edge and the central cloud. If you have a network edge, we're talking 10, 20 milliseconds of latencies, and then you have the central cloud with 100 plus milliseconds of latencies. And this concept of tiered inferencing is going to become important. That's going to be interfacing with the user to enable a responsive low latency network, right? And then on-device AI is another central theme that is going to play out. Today, smartphones are already doing 8 billions of parameters already today. PCs are doing 13 billion parameters, and this trend is only going to increase. So how can 6G benefit by leveraging on-device AI is another theme that I'll talk about in my slides. So with that, with these two sort of trends in mind, it's quite natural to begin to see that 6G will really be the underlying fabric that's going to connect an expanded set of AI-powered devices to enable new services, right? And you take in the on-device AI, you put AI agents, which are continuously processing and streaming contextual data uplink, including sensor data, audio and vision data, and then you enable tiered inferencing, right? Whether it's the edge and the cloud. And 6G is going to be that underlying connectivity fabric. We do see that smartphone will remain as the primary mobile hub for connectivity and compute, but it'll get appended or added with a lot more AI-powered consumer devices, and some of which will also see direct cellular connectivity. And I'll talk to that in my slides. We'll also see more AI-powered IoT devices. We're already seeing that the cars already have like connectivity, but we'll begin to see a lot more devices having cellular connectivity. So now with that in mind, well, how is 6G going to help address all of these things? Well, we see this primarily in like two different buckets. One is the foundational technology development, right? So whether it is you go into existing bands and you use MRSS, and when you have a 6G baseband, that's going to lead to a 50% downlink and then uplink capacity gains right off the bat, right? So this is all in the existing spectrum. Also, 6G is focusing on technologies that's going to improve your uplink coverage. It's not just the downlink that's going to be important, but it's really the uplink. Because a lot of the traffic is going to get generated, and that's going to move in the uplink. And then more capacity in the uplink. Beyond that, when we look at the new spectrum, it's really our like mid-band FR3 spectrum, which is called the golden spectrum. because you can really retrofit existing cell sites with a wider band 6G systems with anywhere between 100 to 400 megahertz of channel. And you can get really address the capacity needs, the 5x increased capacity needs. And all this is being done by keeping cost and deploy and then the device performance in mind. So this is sort of the one bucket. But if you step back and say, well, okay, why do I need all these things? What is the new user experience? What kind of services are we talking about? We're primarily, basically bucketized into three different pillars. One is the agentic AI and extended reality experiences, right? So whether it's a personal assistant, a see what I see, where you just wear your glass and you want to capture a soccer match, or you are walking downtown and you want to upload that to your Facebook account, or you do an avatar calling instead of a WhatsApp call. So these are the types of much more natural interactions that an agentic AI with an extended reality is going to enable. And then we'll go into the underlying technology enablers. We call it collaborative communications and distributed compute. Then the next pillar is AI-enabled context-aware communications. And this is where having your on-device AI is going to become more and more aware of the user context. How do you use that information to enable a much more responsive network, like, for example, a real-time gaming service or enhanced IoT services? And we'll look into the technology enablers, which is an AI-native protocol and user experience-aware RAN. And finally, you look at enhanced network efficiency and services. Whether if you now go into the paradigm of a digital twin network as a platform, how can you use that? And that's going to basically consume a whole bunch of data from all sorts of users and devices, and you enable inferencing as a service or sensing as a service. So we're going to look into that as well. So it's just so the main thing to keep in mind is 6G is not just going to be about more capacity and more spectrum, but it's really going to be about these fundamental new user experiences and services that 6G is going to be enabling. So often people ask, okay, so if we begin to unpack agentic AI and extended reality, what sort of throughputs are we talking about? Is it gigabits per second per user? And the answer is no. Right. If you look at personal AI assistant, where the user is getting real-time responses to a user query, maybe the user is looking at a building and says, hey, what am I looking at? Right. And so there's some contextual information that kind of comes downstream. We're looking at 1 to 5 megabits per second, really, per user on the uplink, and 1 to 5 megabits per second on the downlink. However, when a lot of users begin to do this, or when a user begins to do this repeatedly over a period of a day, your gigabytes per month quickly begins to add up. If you use personal assistant just for 40 minutes a day and assume just a 2.5 megabits per second uplink and downlink traffic, then you quickly get up to more than 40 gigabytes a month. That more than doubles the average monthly consumption of an average user today. Or if you do see what I see, a live video streaming of the user surroundings, maybe you're taking a bike ride and you want to stream that in the uplink and you want to capture your ski trip. All that, right, just 20 minutes a day, it's 50 gigabytes a month. So very quickly, your gigabytes per month is going to compound. Now, when you get into much more of an AI-based personalized experiences, we're entering the domain of digital companions, where their videos are being rendered in the downstream. You have interactive gaming. Maybe you're playing Pokemon Go without looking at your smartphone, but through your glass. Or whether you're doing an avatar call. Instead of a video call, it's much more of a realistic and a lively interaction, more immersive. Very quickly, you begin to realize that if you take a look at 5G with, say, 100 megahertz of mid-band spectrum, you can only do 5 calls a second. And so we would need that extra spectrum in the mid-band, the 100 to 400 megahertz. If you have 500 megahertz, then you can get up to 25 calls simultaneously, right? So as we move into this transformation we expect the data volume as well as the capacity needs to increase, and that's where 6G, the new spectrum, is going to come into play. Now, the other thing is, imagine the world where I have a wristwatch, I have a glass, and a companion phone, and I'm going to be walking around doing my daily activities. Clearly, if you just run all of the AI models on these sleek form factor devices, you're going to run out of battery, right? And that's not going to make for a good user experience. So when you have good network connectivity, you want to offload some of these models onto the network edge. And that's where distributed compute comes into play. Whether it's rendering or whether it's generative AI or like small language models or large language models or perception, when you have good 5G, 6G connectivity, you want to offload that to the edge. The other one is collaborative communication. Suppose you're going out for a jog, and I have a glass and a watch, and I want to leave my phone behind. My glass has cellular connectivity, and my watch has cellular connectivity. They both, if they collaborate together, it leads to a much more compelling user experience. So I have a slide on each of them to make understand better, right? So as I talked about, distributed compute is really about enabling longer battery life and getting access to larger models from all these form factor devices, right? So whether it's rendering, perception, or generative AI. And then, right, so here, 1 second. I click too quickly. Okay, so and then the other, the paradigm is about how on-device AI can enable 6G AI native and user experience aware protocols. Now we take cloud gaming as an example to illustrate. Suppose the user is playing on a console, a cloud gaming application, or on a phone. The on-device AI already these days can detect what's running on the device. It can extract traffic characteristics, whether it's the frames per second, your burst size, is it a low latency requirement, what's the QoS requirement. Now, in the 6G era, it can pass on a lot of this information to the network, which can then implement an AI native protocol, right? And that is the network parameters, whether it's the different layers of the 6G protocol stack, whether it's the MAC layer, RLC, or PDCP, or also some of the power save parameters, the CDRX parameters, or even the quality of service parameters can all be adapted to serve the user. So the user gets a much more enhanced user experience. And we've already tested this out, right? So if you take cloud gaming as an example, and we don't adapt the network protocol parameters to the user application, then we are seeing like latency spikes when there's interference, when there's a low latency traffic, and so on. But with this adaptation, live adaptation, AI-based native protocol, our latencies are coming down significantly. And the user sees a much more seamless experience. And we're already seeing this with cloud gaming, and sister examples would be like a Teams call or a WhatsApp call or an XR-like experience where the requirements are going to be a lot more stringent because when it comes to latencies, it's not your 50th average latencies, it's the 99th percentile latency. Because you see that glitch when you're in the middle of a game, you're never going to touch that device again. You would like to go back to your home and have a wired experience, right? So that's where AI native protocols become very, very important. Okay, now if we switch gears and look at from a network perspective, and as Brian also alluded, the fusion of AI and wireless is going to play a significant role in reducing OpEx and enabling new services. Now, so when you look at real-time network efficiency optimization, right? So already their operator efforts are using AI-based tools for predictive maintenance. But I think once you throw in, go into a digital twin-like paradigm with full automation, you can enable intent-based orchestration that's really adapting to the user and application needs, right? And also, because you have on-device AI now, and if that's leveraged properly, maybe a premium, you can really enable a personalized and a tiered service pricing, right? So I'm a premium user. I want to have better experience. My on-device AI can give you the user intent, the context awareness, and then if I'm a premium customer, I can get better user experience. And also the third, pillar is really as AI agents begin to percolate through all these devices, the need for natural cellular connectivity will increase because you have to talk to the cloud. Whether it's a glass that has cellular connectivity, a watch, or a humanoid robot, right? So you begin, or a connected camera. That then opens up this paradigm of, and they all would want to offload some of their models to the cloud or the edge, and that opens up this paradigm of really the network digital twin, and as well as inferencing as a service, which I'll get to in the next slide, right? So when I just take a step back and look at real-time digital twin, it's really going to be ingesting a whole lot of data, right? Whether it's sensor data or device telemetry, or if it's an XR device, the 3D maps, and then to use all this information to then provide some services to these users. Whether in the case of XR user, it could be the 3D map of the surrounding. Instead of the user figuring it out live, a 3D map is downloaded. Or if you're a drone, then planning and congestion control as an example. If you're a smart city, by using sensing as a service, then you could enable perimeter safety and presence detection like services, right? So, and then my final slide is it's really this paradigm of network inference and compute as a service, because the reality is as AI agents begin to scale on these devices, and each of these devices will have different types of workloads to offload to the network, right? Whether some of them will have a perception workload, which is very uplink heavy. Some of them would want to have rendering done at the network, which is very downlink heavy in terms of traffic. So how is the network going to manage and orchestrate the communication and compute workloads across these devices, whether it's rendering, perception, or generative AI-based user experiences? And that's where we feel 6G services can offer, compute as a service, or like inferencing as a service with privacy and security, right? Where the user feels as though the model is running on their device, but it's actually running at the edge over the 6G fabric. So, and again, I could spend a whole day talking about it, but I hope these types of user experiences and the services give you a flavor of how 6G is going to be much more, more exciting than a much more linear transformation, right? It's not going to be just about yet another mobile phone with higher throughputs, but it's really going to be about enabling these newer user experiences. So with that, I pause and then I hand it over back to Gabriel.
Yeah, fabulous. Thank you, Hemanth. Thank you particularly for bringing the sort of user or customer experience into the discussion. Obviously, that's the key thing. I also really like your tiered inferencing kind of setup and structure. I was going to push on because we have to push on for time, but a terrific question has just come in from someone I know is from an operator very involved in this in NGMN and other places. By the way, we don't read out your name or your company name if you do ask a question. But I'm just going to hit you with this one straight away, Hemanth, while we're on topic. So the question is, the channel bandwidth requirement is stated as 500 megahertz, slide 7, agentic AI, which is unavailable at low mid bands. Therefore, is there an underlying assumption that operators would require to deploy networks with higher frequency bands with poorer propagation performance, and this would drive massive network densification to deliver contiguous coverage, including indoors? The question is whether this is seen as affordable. What is the customer's propensity to pay for these AI services? Any thoughts? So it's a big question. That encapsulates actually about half a dozen of the other questions we've had come in. But I know this person works at a big operator and is very involved in 6G himself.
Yeah. So, and I think, thanks for that question. And as I mentioned, right, so if you just have 100 megahertz of existing mid-band, and these new agentic AI and extended reality type applications begin to take shape with sleek AR glasses, then yeah, you would need our FR3, the golden band spectrum, to essentially scale. And the good thing about FR3 is that you can retrofit existing cell sites. So you don't need to do any additional densification of the sites with massive MIMO or like giga MIMO and basically retrofitting existing sites. You get that extra spectrum. And that 500 number, megahertz number is just a representation. We understand the reality is going to be anywhere from a few hundred to 400 or 500 megahertz, depending on the region and the operator, right? So, but it's just to make the point that you would need that extra spectrum as these types of services scale.
Okay, we're going to come back to the densification point as well, because we have another question from a well-known operator CTO. So I'll come back to that in the Q&A. For now, though, thank you very much, Hemanth. I'm going to crack straight on with the Orange interview. So we're here with Eric Hardouin from Orange. We're going to talk about essentially the 5G to 6G transition and what's going on in standards and why operators are interested. Eric, great to have you with us. Please tell us a bit about your role and what you do at Orange.
Yes. Hello, Gabriel, and hello, everyone. So my role in Orange is to lead the design of the technologies for the future networks that we are operating in Orange. So that includes mobile networks, fixed networks, and technologies for homeland, essentially Wi-Fi. And we address that mostly from a technological perspective, but we also look at various issues which are related, like business models or how it affects society in a wide sense.
Sure. So that's a lot of technology, and it sounds as well that's a group level role at Orange Group.
Yeah, absolutely. So I'm part of the research organization. So we manage the research for the whole Orange Group, which includes that in the end impacts the 26 countries where we operate, as well as Orange Business, which is our business division for enterprises, service to enterprises, and also our wholesale division.
Cool. So thanks for joining us today. We're here to talk about sort of wireless and mobile networks from sort of 2030 kind of period and leading into that and on. So there's lots in that, of course, but the big topic, I suppose, is 6G in some sense. A lot to do before we get there. Tell us like how and why Orange is engaging with 6G.
So why? Let's start with the why first. So 6G is at the moment, and since quite, at least 5 to 6 years, is focusing a large part of the industry interest because it will be defining the technology that we will operate in the 2030s. And of course, Orange being one of the major worldwide operators, we want to be part of this. We want to contribute to defining it, also to make sure that in the end it will make sense from a technology and a business perspective. And according to this, we believe that 6G should really bring value to our customers, and that's the case for all the technologies that we have been deploying so far, of course. But we're seeing that for 6G, we need to have a particular attention of the real value it will bring to our customers. In the past, we had a tendency in our industry to have a rather techno-push approach, so leveraging the progress of science and technology to push the limits of what is achievable in terms of data rate, capacity, latency, and later on trying to identify what we could do out of those performance to propose new services to our customers. And we've seen that we have reached a certain level where we have so good performance that we still don't know exactly what are the services that will bring real value to our customers that can take advantage of this performance. So we believe that now we are at a time when we need to think first in terms of real value, and then the technology should be a consequence of this, but not the cause. And that's one part which is very strong in our vision for any future network technology, not only 6G, by the way, but of course 6G, because there is a lot of work ongoing these days around it. And value is one part, but another part, which goes also hand in hand with it, is the sustainability approach. In the past, we were designing networks having in mind cost and also energy consumption. But now we with the conscious that we have grown in the last 10 to 15 years about the wider environmental impact of our networks, we cannot ignore also the carbon emissions which are associated with the technologies that we are deploying and running. And that goes beyond energy consumption, which remains a central pillar of what we need to reduce, both for in terms of operational cost, but also in terms of environmental impact. But we need also to take into account all the carbon emissions which are associated to the manufacturing of the equipment, its transportation on the sites where they are deployed, and also their disposal at the end of their lives. And that's for, I would say, a metric that we can now better estimate, CO2, but that's not the only impact. There are also impacts on water, for instance, that are much more difficult at the moment to identify, and some other impacts as well. But we really need to take that into account in the design of 6G. And I realize that I'm maybe anticipating in further parts of the discussion, but still, that's also one of the reasons why NGMN published last year a position paper where we said that we wanted 6G to be compatible with the 5G hardware as much as possible. And we think that that goes really in the direction of enabling us to reduce the need to deploy new hardware, also to minimize our CO2 emissions.
Yeah, I mean, I think all those comments you're making are very consistent, I guess, with other. You know, you had your 6G white paper, or in 2024 had a lot of those messages. Right. Obviously, the NGMN work is a sort of joint operator project. Worth noting, I suppose, for everyone that Laurent Leboucher from Orange is chair of NGMN currently. Took over this year.
And I realized I didn't understand the how part of your question. How we are engaging in 6G. So you mentioned that, yes, Orange and Laurent Leboucher, who is our group CTO, is chairing the board of NGMN since the beginning of this year. In addition, we have also a strong involvement in European projects. We have been part of EXA-X and EXA-X2 flagship projects. And now we are technical manager of the Sustain 6G Lighthouse project, which is a European project addressing, on the one hand, how we can make 6G the most sustainable possible, according to the 3 dimensions of sustainability. I talked earlier about the environmental impact, but there is also, of course, the economic impact, because we want 6G to be sustainable for all its stakeholders. That means that we need to enable with 6G a business that will allow us to compensate the investments necessary to deploy the technology. So that connects with the value that we discussed earlier. And the last part of sustainability is the societal or the social sustainability. And this one is rather, or at least what we Orange we put behind this term, is the fact that our consumers need to trust the network. They need to trust that when they will want to use the network will be there with the right level of performance. Also that it will be secure, that it will be resilient, and all in all that this network will be able to answer the needs of the customers and beyond that of the society as a whole.
Yeah. Three strong pillars there. So, Eric, you're kind of representing a group with 26 operating countries, effectively. You've got good alignment in NGMN. You're going to get a hearing, and you're obviously talking to people in the industry and the ecosystem right across the world, right across the industry. How do your sort of priorities and ways of thinking, how do they sort of resonate in the ecosystem? Do you find people are more or less on board with what you're saying, or there's work you're doing there?
So when it comes to value, and sustainability, which are really the central pillars of our vision for any future network technologies. Yes, there is a broad consensus that yes, definitely 6G should bring value and 6G should be sustainable. It's very hard now to see a 6G presentation from any vendor that doesn't mention sustainability as a key objective. The difficult part starts now, I would say, with the start of the standardization in 3GPP. It's about how you transform those principles into concrete technology designs, and also how we specify features that will help us to go into this direction. And here, when it comes to sustainability, what is in the hands of the standards is two things. I think it's about minimizing energy consumption, which is what we have been trying to do since more or less the beginning of mobile technologies. And there is also, and that is new with 6G, I think, is the fact to try to understand what are the hardware implications of any feature, so that we can say, okay, if we go to this, then we will need to change the hardware. And that goes back to this requirement that we have set with NGM, and that we should strive for hardware compatibility between 5G and 6G. And again, it's important to emphasize that this is only applicable when you don't need a new frequency band. If you need new frequency bands, you will need new antennas, new RF, new equipment. There's no question around that. But there are areas where we won't need extra capacity. Thinking in terms of rural areas, for instance, and in those areas, we can keep the bands that we will have with 4G, 5G. So no need there for new bands, no need for those extra equipment. So we need to really take into account those objectives within 3GPP. And this is really the start, because the very first working group meetings during the 6G study item, they happened in August. So less than 1 month ago. So we are really at the beginning. So we hope that we will move from, I would say, high-level objectives to real concrete implementations into the way standardization will work.
Yeah, it's a big challenge for you guys, right? Because you've got these values, you want to translate them into standards and specification, ultimately products and networks. But it's to me anyway, it looks like a compressed timeline, right? You've got study phase now, and then people are anticipating an actual standard, a well-specified standard by what, 29, 30, that sort of period? It's a lot of work.
Yeah, so if I remember correctly, the date that is set for publishing the specifications is not before March 2029.
Yeah.
So that's the earliest date, because the exact date is not decided yet, but at the earliest it will be March 2029. We in Orange, we believe that it should be later, because and that's a point of no consensus in the industry. You have some companies who would like 6G to be available as soon as possible, and others, and we are part of them, we believe that we really need to take the time to do it right in standards. And in particular, we need to let us sufficient time to take into account the lessons from the 5G deployments, and particularly about the 5G standalone deployments, which are quite recent, at least in Europe. And this new core network really introduced new features like slicing, for instance, which is really something very differentiating compared to previous generations. And we are really at the start of understanding what we can do with it, what also is the interest in terms of business from our customers, and how it will work really when we will be able to move to almost static slices as we have today to more dynamic slices that we expect to see coming in the next years. And all of this will, of course, be the basis for the 6G design, and specifying things on which we have little return from actual experience is a bit dangerous. So that's one thing we need to understand. We need to take into account the lessons from 5G, but also we need to, coming back to this value part, which is very important for us, we need also, we think, to understand beforehand what will be the real, I would say, the real interest from our customers for the features that we are planning to specify. And some of them, they are obvious, like everything related to capacity improvement. We believe that, yes, 6G needs to bring solutions for increasing the capacity of networks with as much as possible little impact in terms of cost and energy consumption. But others, which are related to services, are less unclear. And we need also to find some ways to sense the market and the interest from customers before being really serious in specifying them. So as you said, the window is very tight because those features that will be investigated in study items, and we need by the end of the study item to have both some clear vision about the technical solution, but also about, I would say, the business appeal of those the features that those technical solutions will support.
Yeah, lots to do. Eric, thank you very much for talking to us today. We really appreciate it.
Thank you very much, Gab.
Okay, so we should be back with everybody here live now. So that was great of Eric to talk to us. I think the one key point I'd like to make is that they are Eric's very deeply involved. He's been involved in this for a good number of years. They're very considered comments and really something you have to listen, pay attention quite closely to. It's a shame he's on holiday this week. Hopefully we'll have him live next time so he can take some live Q&A with us. But thank you, Eric, if you're watching back on the recording. So we're going to move now to the panel session. We've got just about 25 minutes or so, not quite left. I'm going to ask our speakers, Hemanth and Brian, to turn the cameras and microphones on again. And I'm also going to introduce JD Griffiths from NextG Alliance. JD, if you're there, could you please, first of all, welcome. Great to see you, and thanks for hanging on with us. Could you just tell us a bit about, I guess, who you are, what you're doing, and kind of what NextG Alliance is doing, why you're there, and what 6G is for?
Sure, yeah, of course. So I'm JD Griffith. I'm the managing director of the ADIS NextG Alliance. So NGA started about 5 years ago, kind of really to be the first North American regional support organization for 6G development. So looking at, taking some of the lessons learned from previous generations in 4G and 5G, how can we take some of those lessons learned, even though we were already in the midst of 5G deployment 5 years ago, but we're also gaining a lot of information in that process. How can we start applying that to the future of 6G? So as Brian noted in his presentation, a lot of our work has been focused around pre-standardization research and technical developments for 6G. What does the North American market need? What are the technologies needed to support it? How will that, make its way into groups like 3GPP or, the ITU, IMT 2030 development process to make sure we're representing the North American market well. But also now that standardization is kicking off in 3GPP, we're also taking a more concerted look at what comes after standardization. So when NG was created, it was this research to realization vision. So everything research, standards development, but also manufacturing, market readiness, commercial deployment, and realization. I think it's really easy to talk about, especially this early in the process, these are going to be bright, but we also have to keep in mind of the hype cycle that we saw in 5G and the consequences of that going into 6G that we saw. Yeah. So that's something we're really trying to take into heart in this next phase of both 6G and the NGA, is looking at what are the concrete business cases, what does that mean to infrastructure vendors, what does that mean to operators like AT&T, what does it mean to chipset companies like Qualcomm. What are all the piece parts that need to come together to deliver the end-to-end solutions that do have a clear demand, a clear commercial use case that could ultimately help this industry grow.
Yeah, I think that's useful to have a market view after day one, right? Not all get built up on the launch day, as it were. Thank you, JD. Also interesting to see, 5 years of Next G Alliance. It's interesting from my point of view to see, my career, we've had a pretty good unified European views over the years. And I guess Next G Alliance is a kind of a poll for US and North American kind of interest to at least kind of collaborate and, come to where they need to. And obviously it's not a collab, it's fully in accordance with competition law and everything, but it's building up a sort of a view from that market, which is really good. So I do have some questions sort of pre-prepared, which I've shared with the speakers. What I'm actually going to do, though, is take a couple of the audience questions coming in, and these are just kind of off-the-cuff type things for the speakers now. So there's several around this theme. So I'm going to read out the first one. This is actually from an operator CTO here. And he asks, how important will small cells or different grid pattern be to 5G advanced and 6G? There's another question from a vendor, big vendor. 5G densification doesn't seem to be massively rolled out, probably due to cost and other reasons. What is the operator point of view to mitigate this and densify the network? These are obviously massive questions. Let me say, Brian, it's unfair to land it on you, but if you want to have a little go at it, and then I'll ask Hemanth, to come in as well. I mean, you can't really answer that in full, I'm sure, but just maybe scope out a bit the thinking.
Yeah, certainly. Yeah. So the densification question, ties into the spectrum availability question and also the use cases, right? Because, if you look at millimeter wave use case, for example, you have more bandwidth, which means higher data rates because of the propagation characteristics as you move up in frequency. So there's a lot of different elements to that all need to be tied together when you look at that. And then, of course, you brought in the business case analysis, the cost for densification, which runs everything from equipment deployments, to backhaul to energy. You have all those that tied together. So yeah, it's definitely a consideration, and a planned deployments to meet the specific needs. Certainly we see the densification more in the urban areas and suburban areas where you have the population densities and the need for deploying those higher data rates that those consumers demand. And also you see the fixed wireless access play as well come into that. So I know that's probably not a definitive answer, but it just shows that there's a lot of different considerations that need to come into play when you look at that question on densification and small cells.
Yeah, Hemanth, do you want to come in on that at all, or shall I move on?
Yeah, I just want to add that when we move into 6G, that's one of the key considerations, right? Not to basically being able to retrofit existing cell sites to add that extra capacity. And so that's where this upper 6 gigahertz band and then the FR3 band is this golden band that allows us to do that and give that extra capacity boost without having to densify further, right? So I just wanted to add to Brian's comments.
Yeah, and I mean, I think even in that case, though, it seems to be a feeling that operators obviously want to use the site grid. They've been quite clear they don't want to over-densify or have all the costs associated with it. But I think there's also a kind of a realization that if you're shooting these higher frequencies off of rooftops, there's some sort of limitations of physics. So you probably are going to need, certainly in the urban canyons and things like that, to sort of fill in a bit for, I guess if we're thinking of those glass type applications you had earlier, you're going to want some pretty secure coverage, aren't you?
Yeah, that's going to require more, obviously, because of physics, more antennas at the base station, right? So We're still seeing from the glass standpoint, right? Beyond 2 antennas is going to be hard. But however, if you go to these slightly higher frequencies, you may be able to pack more, right? Because it's just the wavelengths get smaller. But really, I think basically more antennas at the base station, and then really we don't need to be going to the millimeter wave like spectrums, right? It's really upper 6 gigahertz is not a whole. It's still a lot better propagation, right, compared to millimeter wave. So
yeah, and those technologies look pretty promising. Already some pretty good. Some sort of field test data from sort of obviously completely pre-standard, but using these kind of GigaMIMO type systems. It's looking quite good. Hemanth, to you again. And this riffing a little bit off of Eric's comments around sustainability. Hard question again, but just give us your thoughts around it. Are 6G technologies going to reduce radio power consumption? Now, obviously that's a massive question, but maybe just frame a little bit your thinking on energy use and power consumption, and I suppose really energy efficiency.
I think that is also a key pillar that's going into the design, from the ground up. Like, for example, on the device side, right? So we want to make sure that the advanced coding and modulation techniques do allow us to essentially reduce the device complexity and power, right? So that I had covered that in my slide. So, and then also on the on the network side, the whole thing about using automation, right? That's also going to bring down the OpEx, considerably there, right? So those are two angles that are, I think, are at the forefront. So I'll let Brian also comment.
Yeah. I mean, it definitely, energy consumption and sustainability is one of the things we're looking at too as we move to 6G. AT&T has a really a 3-pillar strategy that we're looking at. First, is mitigating the impacts. We have a goal to be carbon neutral by the end of 2035, and we are looking at science-based greenhouse gas emission reduction targets. Obviously, we also have to mitigate the risks that are associated, with more frequent and severe weather, events. And as we transition into the net zero economy, we need to understand what those potential threats are and how we can mitigate those. And finally, seize the opportunities that are going to be available by deploying renewable energy and implementing sustainable business practices, and collaborate with customers to make sure we deliver solutions that could help reduce emissions as we move toward 2035.
Yeah. Good stuff. Thanks, guys. Move on the topic a little bit. Back to JD. JD, tell us a little bit about, I know you've been working with some of the different kind of end user communities, different verticals, ultimately the consumers of next generation wireless. What are some of their sort of, basically what are you finding? Do they know what you're talking about? Are they wanting to have input? How is that sort of shaping?
No, that's a great question. I think we've seen with the industries we've engaged with, and I would say the industries we've kind of prioritized engagement from NGA has been, the industry is ripe for I'd say wide area mobile telecom adoption, whereas outdoor use cases, large coverage areas, because with predominantly indoor industries like we see with healthcare, some industrial automation, we're still interested in those, but we do face more competition from traditional wireline communications like Ethernet, fiber optic, as well as Wi-Fi and other low power wireless technologies. So we talked quite a bit with like electrical utilities, the agriculture industry, public safety. And the couple of key takeaways when we engage with these verticals is a lot of times when we start getting to the end user, they don't really care what G it is. They care that it works. They care that it reduces operational costs. Increases their capacity of whatever whether it be their labor force to augment the labor force to make it easier, increase the capacity of the electrical grid because it provides them more ability to communicate between different nodes of the network and steer power correctly, helps first responders have better situational awareness before, at, and after incidents. So, but they don't really care that it's 5G, 4G, 6G, 8G. They just care that it works and they get their job done. I think that's one thing that, at least for a lot of our members, especially the ones that have been steeped deep in R&D, like, well, what do you mean? It's like, yeah, it turns out not everyone cares that 5G is, one more than 4G and 6G is one more than 5G. But that said, they do care about the capabilities that each of those technologies provide. And so with our engagement with the verticals, a couple key things, a lot of their biggest interests are things that I would say aren't on the flashy 6G technology radar. They want a solid path to IoT support. We heard this quite a bit from like the smart metering industry. What is, there wasn't really a 5G equivalent to LTE Cat-M until eRedCap, sort of, but they're also talking about devices that have a 25 to 30 year lifespan. So now they're trying to weigh, do I invest in eRedCap in the hope that 5G sticks around for another 30 years? Do I wait for 6G low power wide area? And I know this isn't as flashy as like some of the AI use cases that are expecting high data demand, but these are, customer driven capabilities that are being demanded by our consumers. Similar to agriculture, this one's always been a tough nut to crack because it is inherently a rural use case. And therefore, under the model that, okay, we're connecting consumers, individual persons, it does not make a lot of sense to invest invest in coverage in some of these areas. However, when our discussions with, one of the Canadian operators, TELUS, they have a subsidiary, TELUS Agriculture Consumer Goods. We've been talking with their folks that handle a lot of their consulting into the cattle business. And it's like, yeah, we have a customer that has no coverage at a feedlot that has maybe 180 staff. I'm sure every operator's like, yeah, that doesn't make a lot of financial sense to cover that, but they have 200,000 head of cattle. Now, 200,000, even if it was a $10 a month subscription, that's a significant amount of revenue. And so that we do have to kind of change some of the thinking in the industry. We're looking at some of these verticals that we're not connecting individual persons. We're connecting, endpoints, whether that be employees, whether that be, cattle for health monitoring, whether that be machinery for and asset tracking. And that's something that we've kind of noticed, that a lot of these capabilities that the customers are asking for are not necessarily the ones we've been dreaming up for 6G. But at the same time, we have to kind of change our thinking of like, do we want to continue with this consumer focused view? Do you want to look at businesses, that business enterprise angle in earnest? What does that really mean for the capabilities we need to deliver?
Yeah, and I think a lot of these sectors as well, they're very concerned about some of the points Brian raised there about resiliency and things like that, as a sort of, these are kind of very important factors to them. We're going to move on, JD. Just in interest of time here, this is going to land this one on you, Hemanth. Very good question. Again, hard to answer. Will the net benefit of AI on network efficiency, e.g. spectral efficiency, offset the traffic increase generated by AI itself? And I suppose if we look at your tiered inference model there, we should really be expecting NPUs and inferencing on base stations, right? As one example of that. Just talk us a little bit about, I know at Qualcomm you've done some sort of modeling around, expectations for AI traffic generation. You showed some examples. Again, just elaborate a bit on that thinking.
Yeah, as I was sharing, right? So I think when we move into this agentic AI and extended reality type applications, whether it's a personal assistant or a see what I see or like an avatar call, if we look at the gigabytes per month, that clearly is going to go up, right? So there is no, even with a very few megabits per second uplink and downlink, because just the nature is just going to be a very chatty conversation. It will not be limited to a user punching things on the keyboard, right? So it's going to be a lot more frequent and a chatty conversation. And so that's going to increase your gigabytes per month. And also, as more and more users are beginning to do this, that's going to put a load on the capacity. So that's what we were essentially saying, that if you have suddenly 10 people in a cell doing avatar calls, that's going to put a load on the existing 5G network, and we do need that extra spectrum. However, there's this other dimension, which is AI itself is being used to improve the efficiency of the network, right? So that pillar will continue to happen. And so there, for example, whether it is AI native protocols, right, wherein the network becomes a lot more responsive to the user. If I'm playing a gaming or if I'm an XR service, on-device AI is telling the network, hey, these are my needs. This is what I'm actually doing right now. And so the network can respond more efficiently and actually satisfy user experience, right? So that dimension will also happen. So these are like, one is on the x-axis and the other one is on the y-axis, right? So both are going to be important. And of course, the fact that you have, the other thing is that AI is also being embedded into every layer of the stack, including the physical layer, right? So whether you have feedback, CSI feedback is a classic example, or AI-enabled beamforming, that's going to improve the efficiency. It's going to reduce the load on the uplink traffic, for example, that the signaling, the CSI feedback itself will take. Basically, you can do a lot better with lesser overhead, if that makes sense, right? Basically, reducing overheads and improving the efficiency, that is going to be very important. And the other axis is just the user patterns themselves changing, right? Where it's just the volume of data is going to increase, right? I hope I was able to.
Yeah, I think that's clear. So maybe have a kind of a fun but serious, but mostly fun question to finish on. Let's go with you first, Hemanth, and then Brian and JD come in as you will. From an operator in Canada, not the one just mentioned by JD. The question is, what is the most important technology adopted in 6G comparing to 5G? For example, the most important in 3G was CDMA, 4G was OFDM and DFT, 5G is polar code and LDPC, massive MIMO. What are the sort of buzzwords that will define 6G from a technology point of view? I'm thinking on my side here, Hemanth, I've got AI, I've got sensing, and I've got integrated network and device computing. They're my three things. I guess it's going to be AI, but give us your thought.
Yeah, I think it's going to be AI native. That's clearly right. There's going to be tiered inferencing, and I think you hit it right. And also the underlying advanced coding and modulation. We should not forget that, because with the existing cell sites, existing spectrum, if you can get better capacity, squeeze a lot, I said, like, even with the current mid and low bands, you get 50% more capacity, right? So that is going to be very important, even from a cost perspective, right? So we should all three are going to be very important.
Yeah, good stuff. Brian, you want to have a go at that?
Sure, I'll take a go at that. Touching on some of the other questions I saw in the Q&A as far as the waveforms, we don't want to see a completely new waveform for 6G. 3GPP has already agreed that the waveform for 6G is going to be OFDM based. If we had a new waveform, we would have to justify that by what performance gains are we going to get, or what new services would it enable. I agree totally with your list that you mentioned, Gabriel. I would add openness to that. I think, more open RAN, openness in the network, API enablement, including, some of those to enable some of those new services. When we look at sensing, the one thing we're trying to wrap our arms around is, what does that exactly mean? Okay, we can detect objects, but how do we monetize that as an operator? What do we monetize that? And how do we bring in some of the user consent and privacy issues along with that come with that? So there's a lot of questions around that, but sensing certainly is one of the new capabilities. And I would add non-terrestrial networks. I think that's going to be the new thing that's added to bring us ubiquitous coverage. As I mentioned, we're already seeing that in the 5G realm. 4G, even 4G realm. But as we move into 6G, we'll see even more.
Yeah, okay, terrific. Thank you, Ron. JD, you're going to get the last word. You don't have to be a technology, but just a couple of very snappy, how would you encapsulate it when you have to go and explain this to one of the vertical users across the US who might be interested?
Yeah, I would say, besides all the great points that y'all made, I would say one thing that I think is can be the game changer if the industry chooses to make it the game changer for 6G is going to be device diversity or endpoint diversity. What we want to look at, how we want to look at that. We haven't really had a generation that's had to be able to comprehensively address everything from the highest performance fixed wireless access and top tier smartphones all the way down to low bit rate, high lifespan, IoT devices. And there's a lot of demand in the North American market to have one generation to rule them all that can handle everything, and we don't require, stacking on every single piece of the network. Where you have to maintain 2 or 3 generations at a time to be able to serve your entire customer base. We need to be able to keep in mind that operators have a variety of stakeholders that they don't want to have any more generations of technology on their network than they have to. Mm-hmm. And this also gives more choice to how we can engage with potential vertical customers, because some will have a lot of IoT focused, equipment monitoring in both urban and remote areas, all the way to, I want those AR, VR, AI-enabled headsets to help with the equipment maintenance, help people out in the field to connect to the back office. So I think the device diversity is can be the game changer, but we have to work together to make it the game changer.
Yeah, very good point. So with that, we come to the end of the session. I'd like to thank everybody for attending, asking your questions. We got to a lot of them, not all of them. Unfortunately, if we had another hour or so, we could get into quite a bit more. But thank you for asking them. Look forward to seeing you again soon. Just really thanks to all the panelists, Hemanth, Brian, and JD, for attending today. Thank you all very much.
Thank you.
Thank you very much.
Thank you very much, Gabe. Take care.
So, thanks a lot, guys. And with that, goodbye.
Bye-bye.